Hello and welcome to another tutorial. So this time around I'm going to be taking a look at Singleton pattern. Now I have looked at Singletons before, I've used various versions in my own code, but the reason I'm taking a look at them again is I've been doing a bit of digging around into, because there's issues I didn't like with a bunch of the approaches, and so I found a good approach that I really like, that I've made some modifications to, and that I wanted to dive on in and sort of show you how that approach works and go through a few specifics of it and some of the kind of limitations that you can run into, and sort of just give a little bit more info and background there for how they actually work. So let's dive on in. Now, with singletons, you do get at times some very strong views expressed about them of they're terrible and you should never ever use them. And you also sometimes get extreme views of like, no, you absolutely must use them. They're the best, use them in everything. I don't agree sort of with either approaches. For me, I think they're an incredibly useful pattern, that it's very easy to abuse them and it's very easy to dig yourself into a bit of a hole with them, in particular in terms of initialization order and dependencies, and that's something I will talk a little bit about. So it is possible to dig yourself a hole with them, and I think they are, however, a very useful pattern. And I think they're also a very efficient pattern for being able to quickly access things. So let's dive on in with getting this set up. So I'm going to create 3 scripts. One is going to be our core singleton class. This is going to be a generic, and it's going to be a mono behavior, and so it will be able to be the base class for any of our actual singletons. Now I'm going to create a test manager. So that will be one of the singletons we create from this. And just for completeness, I'm going to create another one, because I think it's good to have a couple of these there testing out the code. Now, there are a couple of things that I've already set up in this project. One of the big things is I've set up a couple of scenes and set up a automated transition after a few seconds for it to go from one scene to the other. That's just to make sure that we're able to test things like persistence across a scene and check what happens in terms of initialization. So let's get stuck into setting up the code for this. Now, the first thing I am going to do is I am going to, at the top here, paste in a link. So this implementation of a singleton by a user Cosmic Giant on Stack Exchange is a large part of the base for the implementation here. There's a couple of modifications I've made to address some concerns that folks in comments expressed with it, but I think at its core it's a really good pattern. So I do highly recommend checking that out. That entire thread has some really great discussions about singletons and sort of impacts, things to be aware of. So this is heavily based on the implementation here. So do always make sure you provide credit for things and check what the license is. Stack Exchange is a Creative Commons share-alike one, so you need to sort of be providing attribution, things like of that. So do always make sure you check out stuff like of that. So what I'm going to set up is firstly our abstract singleton, and that's sort of just the core base that we're going to have, but that's not a generic yet. What I will then create is a public abstract class, and this will again still be called Singleton, but this is a generic one. So by putting T, we could use any name actually for it there, but by using those angled brackets, we're indicating that this is a generic. I say that it inherits off of Singleton, but I don't want it to just be inheriting off of anything there that is Singleton. I want to make it clear that T has to be a mono behavior or something based on mono behavior. So when you're doing stuff with these generics, you can restrict the possible types. So you can restrict to particular types, you can restrict to particular interfaces. It's really powerful being able to do that. So I need to keep track of the instance. So we generally use static for that. And I'm having it as private. So I'm not providing any specifier there, so that's good. We have our instance. And I'm going to default that to null, so it's very explicit what the starting state of it is. I'm also going to have a Boolean here, and this is going to keep track of if it's being initialized. So one of the concerns expressed with the original implementation was with the different play mode options. In particular, if you turn off domain reload, static variables don't get cleared out and reset, which is a very valid concern. So I'm keeping track of initializing as a bit of a way of, it's going to allow me a couple of extra options for both being able to keep track of if initialization is in progress, but also be able to provide a fast way for skipping the initialization, which is also handy because there was some concerns there in terms of thread safety. So this doesn't fully mitigate them, but it's a partial step towards it. Now, the other thing I'm going to set up here, and I'll explain why in a moment, is a static read-only and in lowercase object, not uppercase object. This is actually sort of one of the very foundational type in C#. Pretty much everything builds off of object, even things like int and float. So this is our instance lock. Now the idea behind this is to allow us to ensure a bit of thread safety. So what we then have is, and this part is fairly similar to what we normally see in the Singleton pattern, a public property that is of a particular type. We only provide a getter. Now, couple of things that we're going to be doing here. So firstly, in terms of thread safety, I'm going to lock on this instance lock variable. So this will ensure that the block of code here can only be run from one thread at a time. If two threads try and run that block of code while one's already in it, then they won't be able to start that block. So really important for the thread safety aspect. And so you provide a variable that it locks on. There are some really important restrictions with lock. So you shouldn't ever use lock on a variable. So you shouldn't use it like for this. So this should never be what you use as your lock variable. Strings are also, it'll let you do it, but you are actually running a bit of a risk there. But just because of what the C# runtime does with how it manages strings. So don't use a string, don't use this. This pattern here of creating an object and a completely new one, I think is a really good approach. And we essentially use it for guarding particular blocks of related variables. So, okay. Well, one case is we've already got our instance. So instance already exists, already found. So in that case, what we would do is we would check if the instance is not equal to null, then we return it. So most of the time after we've started up, that's going to be what's happening. It's going to be able to be doing, just returning that instance. Now, if that's not the case, we might need to find or create this. So I'm going to set our initializing to true because we are starting that initialization, that search process. And then I'm going to do a search. So all instances, we do a find objects by type. So this is the slightly newer interface. We look for objects of type T, and we provide the sort mode. In this case, we don't need any sorting, so that's good. So search for any in-scene instances of T. So there's a few scenarios of what could happen. In one case, we only have one. So we found exactly one. So in that case, all instances length would be 1. Now, if that's the case, that's actually really easy because we can then say, well, instance is equal to that, and we're done. I'm going to, for now, log out what the results were here. Found exactly 1, and then I'm going to output the type of our singleton. So that's good. So that's one use case that we could hit into. The other scenario that we could hit into is we might find absolutely none. So if all instances length is 0, so found none. Now in this case, what I actually want to do is I want to create a new instance of this. So I will say, I'll bring my debug down. And what I'm going to do is I'm going to say instance is I create a new game object. Now this is not something we would normally do, but in this case is something that we can safely do. Then what I want to do is I want to label this as, there's a couple of different ways. This is very much down to how you prefer to name things. So I am going to put this as singleton, like that. And I'm going to put type of T as the name. You might want to name things differently. So this in particular is very, very subjective to how you want to actually name things in your scenes. So by all means, you might want to modify this. So, okay, we've done that. We've created the object. We add a component of type T to it, and we're done. That's going to create a new game object in the level, and it's going to add that component to it. Great. The final scenario we could hit into, that is not correct. I'll make sure that hasn't gone in. Yep, it added in extra ones. So the final scenario is there were multiple found. Now in this case, what we will do is I will use the first one but I will then destroy the others. So this logic is still the same. So we found, and I will log out the number that we found. So, okay, we use the first one, we destroy the others. Now, this is very heavy-handed, but this is something where it's actually very bad if you have multiple of these. It's very, very bad. So I do want to be quite heavy-handed with this. So index is 1, like that. And then I'm going to debug log error, destroying duplicate type of t on, and then we'll actually output here all instances and the game object name. So we'll just log out whichever one it was found on. And then we do a destroy of that game object. Now, especially doing the game object, not just the component, that is very heavy-handed, and I'm actually okay with that because this shouldn't fail quietly. This should be a very noisy error. Now, with that done, well, we are no longer initializing, and we can return the instant. So that's a big, big, big chunk of our setup there. Now, okay, that's pretty good. There are a couple of other bits that I do want to add into this. So that's our actual property. I do want to grab awake, and I do want it to be private. Now, there's a couple of reasons why I want to do this, and a bunch of this comes back to, doing the find there is not great for performance, especially if you've got this in a large scene. And I wanted to have a means of being able to optimize around that by being able to place this game object in the scene. Because generally you shouldn't be accessing singletons inside awake. That should only happen inside start. That's normal best practice. But I wanted a way to allow it in awake to force the initialization. So what I'm going to do, now this function doesn't exist yet, so I'm going to have a construct if needed that we pass this to, and then I want to have an onAwake function, because there's a couple of useful things there, and I don't want child classes overriding this. So what I'm going to do is provide a protected virtual void onAwake, and then that is where we will do the don't destroy on load as well, because singleton we want it to be able to go away. Well, sorry, we want it to specifically not go away. Now this is something where you could create a singleton that in the onAwake you could override it and remove that behavior. So I kind of like this approach of you specifically can override that behavior if needed. Now in terms of the construct if needed, this is again a static function, and the goal of this is so that if we place one of these objects in the scene, it can just initialize itself rather than having to wait for first access and then do a find. So it gives us a cheaper way of doing that initialization. So what gets passed in? Instance. So first thing, we need to lock, because we are working with that instance variable. Oops, instance lock is what I should have put there. So because we are going to be modifying this instance variable, because I'm accessing this initializing one, I want to make sure it's locked, because awake will run when this line runs. And we don't want it to get into an infinite loop, anything like that there. So I'm going to lock, and then only construct if the instance is null and is not being initialized. Because it can be still null because it's in the process of initializing. So we need to make sure that instance is null and that it's not initializing. Oops. So if that's the case, then what we can do is instance is equal to inInstance as t, and I will for now put in a debug log here, construct if needed, run for type of t. So that's good. That gives us our ability to have it be properly initialized and to do this via awake. Okay, so we have most of this set up. There's a couple of other little bits that I want to sort out for this. So it's possible that this could be accessed while the application's actually being stopped, and that's less than ideal. So what I'm going to set up down here is just be able to keep track of if this is quitting. And actually that would just be protected. Now this, I don't want it to be publicly settable. So that's good. Now what I can do is our private void on application quit, and then I set is quitting to true. I'll put out a log here, quitting in progress, like that. So that looks good. And then what I can check is in our actual setup here, if we are quitting, we return null. So do nothing if currently quitting. So that's good. I don't need to put that in the construct if needed because this is only ever run from awake, which is very unlikely to be running during that sort of destruction phase. So that's good. Now, one of the things that you can run into with play mode stuff, and one of the concerns that was expressed, is the proper resetting of this for when you launch without having a domain reload turned on. Which domain reload is on by default, but a lot of folks do turn it off for speed. But we can, and I've done some testing and this seems to work pretty reliably for working around this. We use a runtime initialize on load method. And specifically, I will do this before any scenes are loaded. So this means before any awakes are getting run, before there's any chance for general game object behavior to be running. So I'll have a static void on before scene load. And what I will do is set B is quitting to false. So we'll just also add a log because I think that's helpful for scene load. So that's good. that is actually pretty much it for the Singleton class. Now, if I set up some usage of that, so what I'm going to do, so test manager here, what I would do is that becomes Singleton test manager. And I will just create a public void, do something. And that is just going to debug log. Hello, I am the test manager. I am going to steal that code. And in other test manager, I do the exact same thing. Like that. So the thing I really like about this pattern is that it does make it very easy to create singletons, which I think is great. Then in our test code, well, in start, let's throw in here a test manager dot instance dot do something, and we'll do the exact same thing with the other test manager. And make sure we've updated our code there. So that's good. So let's test this out. Now I have my test code already attached here. I have not added either of those managers into the scene. So let's see what the life cycle looks like for this. So down here in the console, we can see we get a before scene load. It found no test manager, found no other test manager. The test code did run, and we can see in don't destroy unload, we have our two singleton ones. So that's good. What if I create a empty thing here and I add the test manager onto that? We can see the quitting in progress came up there as well. So with this, I want to be certain that it shouldn't go and search for test manager. It should still search for other test manager and dynamically create it, but it shouldn't do that for test manager. And we should see this game object move down into don't destroy unload. So let's see. So we can see the game object did move down there. Construct if needed ran, so that optimized initialization path did actually run, which is great. And it's persisted across the scene transition. Let's see what happens if we have duplicates. So this will test the code path for us having multiple of these. So we can run that, and we see construct if needed ran for the test manager. Now this is a use case where it will not have picked up that there are actually multiple ones. So that's a minor addition we want to make to this of in our singleton. So we have properly handled this, but else if instance is not equal to null and we are not initializing, then we have found a duplicate. So we're going to log error, found duplicate, and we'll use this. So duplicate one on, and we can say our in instance, whoops, that would go to be in instance game object name. Found duplicate on that, or destroying duplicate. That's better. So I will do a destroy of this. Now that does mean that on awake still actually gets called there. So this could be one where we might want to do some checking for that, but I think probably not necessary at this point. So if we test this out, now we've got two ones here, but the order that awake gets called isn't guaranteed. As we change hierarchy, things like of that, they can get called in different orders. One of these should be destroyed, and one of those should remain. So we'll test that out. So game object 1 is the one that's actually remained. We destroyed the duplicate that was on game object. But that's good. If I created even more again, then it's going to destroy all of the extra ones. So that's good. We have our singleton set up, able to work in terms of it can handle an optimized sort of path for being initialized, where if we place it in the world, it'll get set up in awake. We can make sure that accessing that instance is thread safe, also really good. We are also able to make sure that if the object hasn't been placed in the world, it goes and creates it. And we have a nice simple syntax for converting other things over to this actual sort of singleton, which is really good. So that is a setup that I'm finding really helpful. I have switched over to using this style of singleton for some upcoming projects where I really want to have it be more sort of open and usable in a wider range of scenarios. Now, one thing you can run into if you have a lot of singletons is initialization order issues. That is absolutely a very valid concern. So I do recommend, generally you want to try and avoid one singleton talking to another. One approach that I have seen used and that can be a really good approach is you have essentially a master controller singleton, and it, as part of its load up, initializes the others and in a very strict order. That might be something that you want to do for your projects if you feel it's appropriate. If it is, I would be removing this construct if needed and refactoring that a little bit to have, it's going to be a similar purpose, but it's essentially going to be a forced initialization. But that's something that you might want to potentially do depending upon sort of your use cases. But that is something to be aware of, that lots of them you can run into initialization order issues. So do just be aware of that. But that's the setup. So dive on in and experiment with that. See how you find it in your own projects, see what things you might want to change or improve about it as well to suit your needs. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you've got any questions, chuck those in a comment below. If there's any sort of different ways you like of approaching this, or things that you think could be improved with it, then chuck those in a comment also. And if you're looking for the code for the project, the code is available up on GitHub. There is a link to that in the description below. And if you are looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description also. But until next time.